Right, so in the last video we specified the variable name called directory, dir, which tells us the name of the folder or the location of the folder with respect to where we are in our project directory. And we also created a variable called files, and we used the list.rfiles function to strip out all of the names of the files in there. If I type files again, there you go, it's there, right? So what I want to do now is create, I'm going to call it, well, it's called a function. So we haven't encountered functions yet, so this is new. And all a function is a little piece of code, a little snippet of code that does something very, very specific, and that you can use over and over again without having to write the same code out each time you want to use it. And that's sort of a standard item of code in any language is as a function. Okay, so I hope it'll become a bit more obvious what it is when we write it. But this is going to be an independent block of code that will only work once we call it at a later time, right? Now, to define any function, you do it the same way as you define a variable, pretty much. So I'm going to define a function called get gradient. Pretty self-explanatory, and I'm going to use the function method. I'm going to open bracket, close bracket, and then I'm going to use. We're going to put some stuff in here. I'll tell you what that is next. And we're also going to use a curly bracket and ask you to autocompletes, and we're going to do that. Right, now, I've defined a function. I've called it getGradient, and that sort of relates to exactly what I want this function to do. I want this function to take any of these files, so a specific file, for example, this one, and I want to get the gradient out of it. So I want to fit a linear model, essentially, to the columns in that data file, and then get the gradient that linear model returns, and then spit out that value to wherever it needs to go next, right? So I'm going to define this function. I'm going to tell it to expect a couple of variables. The first one is going to be the dir variable, which is essentially the directory we're working in. And also I'm going to tell it to expect a file name, which I'm just going to call fname. Okay. And the first thing that we're going to do in this function is I'm going to recreate a variable called the path, which will be a sum of the directory name and the file name. Okay. So the directory name is just this. So that tells us where to go to get the files, but it doesn't tell us a specific file to get. So to generate a string that tells us that, I need to do the following. I'm going to use a function called sprintf. Okay, that's a common R function which allows us just to format a string. Don't worry too much about this. So I'm essentially having two string parameters that I'm going to put together in quotation marks, and then I'm going to call dir and fname respectively, okay? And that will give me something that looks like this, but with a specific file name appended onto the end of it, okay? And that's the path of the file. Okay. What I'm going to do next is I'm going to read the data in that file, and I'm going to read it to a variable called df for data frame. Now, you did this last week using the read.csv command, and I'm just going to call that path variable, which is going to tell our studio exactly where to look to find that file in this whatever file it's looking for. Okay, and I'm not going to plot it. I'm not going to explicitly read all the data in that and then decide what to plot. I know that I want to fit a linear model to that data, so I'm just going to call a variable called fit, and I'm going to use my linear model function to get the fit between my weight column and my time column. Okay, and I need to specify where that data is coming from. That is the variable above I've called df. Okay, and the last important thing for any function is that when I call the function, basically it needs to throw something back out. So I'm gonna later create a variable which will be, I don't know, gradient or gradient value, and I'm going to call that function, and then I'm expecting something to come back at me. So I need something called a return statement, and what the return statement does is going to give back a value that it's calculated, right? So in this case, I'm just looking for the gradient. Now, if you go and play around with the output of the lm function, you'll get a whole table full of information. I know I can access what I need to by doing fit $coef, which will give me the coefficients of that fit. And actually it gives the gradient value second, right? So I'm going to use a square bracket and a 2 to get the gradient out. And that's it. That's the end of my function. Right, let's test that function. So always test your functions. So I'm just going to call a single instance of this function and see what it does. So let's just see if we can use it to give the gradient for my first file in my directory, which is 100822. So I'm just going to go get gradient. I'm going to open my brackets. I'm going to put in my directory variable, which is this, and then I'm going to call that file name, which is this, and then that needs to be a string. Elephant underscore 100822. I'll do control and enter, and there you go. It's told me that it's 31.07899. Okay. Did I actually do this? There you go. Actually, that's what I was looking for, right? So it should spit back. And it's got the reason it's got the time months variable in there as well. That's just how it's looked at your headers and returned the gradient. So don't worry too much about the time underscore months. It's this value here, which is the gradient. So it's telling me that of that data set, of that particular data file, the elephant put on weight at a rate of 31.07928 kilograms per month. Okay. So now I'm going to have a break. And the next thing I'm going to do is I'm going to use the function I've defined there in a loop to get this value, the gradient value for every single one of these files, okay? And then I'm going to sort of use that to figure out which one of those values is the greatest and which file does it correspond to tell you which elephant put on weight the quickest out of these 1,000 elephants, which is what we're trying to find, remember. Okay, so back very shortly.